Alright, in this video I will be showing how to do explicit messaging with an EMX4i Benshaw soft start and a compactlogix in Studio 5000. So I've got up on the Benshaw website. I'm going to scroll to the bottom. There's a document library. Down at the bottom of the document library there are communication manuals. I'm going to be using the Ethernet IP card for an EMX4i. In this, you will see that I have previously set up a generic Ethernet module with an add-on instruction in one of my other videos. This is not required for what you're about to see, but that is why you will see communications already set up with the Benshaw on this page. I am going to jump down to page 16 where it has the explicit messaging information. I'm going to create some rungs here. Make a message timer. And go ahead and just make a cycling timer at 3 seconds. The next thing I'm going to do is go ahead and make a message instruction. And I'll go ahead and do Benshaw software message 1 is what I will name this. Create. And I need to create a tag. I'm just going to move it so that you can see what it is. Benshaw soft start message 1 value is what I'm going to name this. Create new. It'll be a didn't. Put that right down there. So this will be so we can monitor the value that I grab. We're going to do a CIP generic message type and a get attribute single with this. Our path will be, in this case, I already have it in the tree, so I can use the Benshaw EMX4i. You can also use the style that goes directly to an IP address without using this in a tree. In getAttribute single, it has a class, instance, and attribute, and a destination element. This destination element is within my processor, so I'm going to send this to my value page. Oh, I hit enter, I shouldn't have. Now, this is where it opens up to essentially any parameter that you are looking to read from the Benshaw soft start, among other things. Something to note, if you're looking for phase currents, phase voltages, or average voltage, these are output to the motor. So you will not see any good value out of this. I'm going to go ahead and type it in just for the heck of it. My instance in this one for the RMS voltage is going to be 123. The class and attribute is where you'll get caught up because these are in a hex format. And the number they give you over here for class and attribute are not a hex number. My best thing to do is to just go ahead and Google search them. 103 to hexadecimal gives you 0x67. The 67 is what you need to type in here. And the 100 to hexadecimal is It's actually just two numbers lower, and that is where you get 64. So with these numbers typed in, this instance 123 gets me the average voltage. I will apply these changes and save my logic. And as you can see, it is enabled and done. No errors. And unfortunately though, since my drive is not running, I have a value of 0 here. I can jump to another tag. Let me find something that will give me a number. Let's say, for instance, power factor. I'm going to go ahead and jump back in here. My class and attribute are the same for power factor, but I will change down to instance 122. And when that timer runs, as you can see, the value updates to 100 because currently without the motor running, I'm at 100% power factor. So this gives a little indication that it's actually reading a number. Another one would be 133 for trip code. I don't believe I have any faults. So we'll go ahead and run it. 255 is no fault. So really any of these here can be read with the 67 and 64 because they all exist in the 103 class with 100 as the tribute. Alright guys, wanted to do a quick follow-up on this one. The explicit messaging program parameters here have their class, instance, and attributes, but it kind of ends at this network design down here, so there's nothing more below the fault codes in this manual, which this is the newest manual at 2021. I jumped into the older manual, which this one is dated 2020. It is for the same thing though. It's Ethernet IP for EMX4i and 4i. And in this one, you run down, it's got a little less information on other stuff than the newer manual, but it goes through the same thing, except there's a little bit of additional information here because when you get down below fault codes, you end up in parameter list 10.2. The useful part of this is it gives you a class instance and attribute for all parameters in the whole drive. So in this case, for instance, I'm grabbing 64, which is class 100, 64, which is attribute 100. Those are both 100 in hex. And for in this case, I'm grabbing 178, which is the overvoltage level, and it is set to 500 volts. If I want to read something else, let's say, for instance, the start ramp time, I can do 109 for that one, and I'll apply it. And when that message timer runs out, as you can see, it is currently set for a 10-second ramp time. So you can read, or in this case, I can actually set attribute with this timer as well. Oops. Well, let's jump over here. I believe it needs to be 2 bytes. Apply that. I'll set that to 12. Looks like it read correctly. Alright, and then I'm going to jump back over to a get attribute. Single right there. I'm going to set it to the same thing we had in there. And select my Benshaw value I was using, same one here. Or actually, if we want to see something different in there, I can go ahead and grab, I have an array set up, and I'll go ahead and add that one in there. That should be up. Make sure I type that in right. Four. See, tribute. Sure. There we go. So with the correct bits being moved in there, as you can see, that value changed to 12. So this is able to be set up both, these are all being able, should be able to be read as well as written to if you need to change any of the parameters from your PLC. So let me know if you have any issues.